Hello, hi everybody. Myself Halavath Ramesh. Welcome back to our discussion topic. Today topic is very general topic I was choose. So that is the topic name is understanding NMR spectroscopy. How to understand the NMR spectroscopy and what are the main introduction of NMR spectroscopy and some applications and some what is the chemical shift and what are the factor of chemical shift. These things we will discuss today class, and next class we will go in detail about the NMR spectroscopy for explain like 1D NMR spectroscopy, 2D and 3D and 4D, those dimensions NMR spectroscopy in explanation part interpretation we will discuss in next class. So anyhow, today we will talk about the only introduction of NMR spectroscopy. You can see that here understanding NMR spectroscopy, and this is the picture I was here in the workstation, NMR console and the magnet and a probe of section and sample on board. You can see that here you can and myself Ramesh in the learn chemistry, think chemistry and practice chemistry. I will like that quotation. You can see then next one you can see that my name, I did an MSc, MA, BD, MPhil and PhD and in chemical science. Okay. So anyhow, we will move on to that introduction slide. So you can see the first one slide, introduction. The basic what is NMR spectroscopy. So of the important spectroscopic aids that are the disposal of the chemist as a chemist for the use of structure elucidation, nuclear magnetic spectroscopy is one of the major tool. Nowadays NMR spectroscopy, it is very important spectroscopy techniques, especially for chemistry to structure determination. And next one, see the physical foundation of NMR spectroscopy lies in the magnetic properties of atomic nucleus. So the interaction of the nuclear magnetic moment with an external magnetic field B0 leads to, according to the rules of quantum mechanics, to a nuclear energy level diagram, because the magnetic energy of the nucleus is restricted to certain discrete value of EI is called as eigenvalues. So simply we can talk about the NMR spectroscopy nowadays is one of the very major tool to structure determination, and this is the one of the magnetic properties of the atomic nucleus is the main physical foundation. The interaction of nuclear magnetic moment, and if you apply the external magnetic field that B0 lead to rules the quantum mechanics, and then it will be happen the energy level diagrams like ground states to excited states and E1 level to E2 levels. So these things you will call in the eigenvalues. You can see associated with the eigenvalues are in the eigenstates, which are the only states in which the elementary particles can exist. They are also called as stationary state. So what is stationary state means the eigenvalues or the eigenstates which are the only state in which the elementary particles can exist. Elementary particles can exist. They are also called as the stationary states. You can see the next one points you will see here. Through the radio frequency RF transmitter, transitions between these states can be stimulated. The absorption of energy is then detected in an RF receiver and recorded as a spectral line, so the call is resonance signals. In this way, the spectrum can be generated for a molecules contain atoms. Those nuclei have non-zero magnetic moments. You can see here what is chemical shift. From that part, you will understood what is resonance signals and what is the non-zero magnetic moment. You can see what is chemical shift. So chemical shift is one of the major point in especially in NMR spectroscopy. What is chemical shift means the different resonance signals or the group of resonance signals are found for the protons, especially protons. These arise because the protons resides in a different chemical environments. So if we talk about the protons have a different chemical environments. The resonance signals are separated by so-called chemical shift. The resonance signals will depending on the chemical environment that is separated by these called chemical shift. You can see the what are the major factor of chemical shift. You can talk about here factor that affect the chemical shift. For the analysis of an NMR spectrum, it is important to know the factor that affect the chemical shift. You can see the first one, inductive effect. Second one is hybridization of C13. Third one is magnetic anisotropy. Fourth one, mesomeric means resonance effect. and fifth one aromatic ring current effect, and sixth one steric effect, and seventh one is a hydrogen bond. These seven is the major factor that affect the chemical shift, in special in NMR spectroscopy. You can see the sample diagram of NMR signals, how it will come. You can see the NMR tubes with a sample. You can apply the external magnetic field of the B0, and then started the energy level diagram E1 to V2. Delta E is equal HV. This is the resonance signals. So formation of an NMR signals. Then you can see here what is swimming. What is shimming? This is also one of the very important point in especially in NMR spectroscopy. What is shimming? The shim is a device used to adjust the homogeneity of a magnetic field. The process of shimming involves adjusting the current in shim coil till the homogeneous B0 is obtained across the sample. So this is that sieving concept. You can see here that sieving, if there is no uniform of that compound like sample, it improves the magnetic field homogeneity. If the magnetic field is not uniform within the sample, the molecule in different positions will experience different field strength. So this will produce broad, distort and additional signals. This is that called sieving. Next one, see the picture of brief rough diagram of NMR spectroscopy. You can see that sample tube and magnet and transmitter, receiver, amplifier and floater. This is that picture of the NMR spectroscopy. Then you can see here the sum of the detector, atomic beams, pipe species, paramagnetic and diamagnetic properties. Paramagnetic plus and minus, and diamagnetic how the signals will come. Then you can see that what is the outer part of the NMR spectroscopy. You can see top of the sample tube and then air turbines, NMR measuring chamber will be here, and the inner diwar and superconductivity solenoids. Then you can see here the NMR spectrometer instrumentation, generally how that black diagram of NMR spectroscopy. You can see that here sample and detector coils and the RF coils, and those are the two magnets, magnetic power supply, magnetic field sweep, and the transmitter, then receiver 2 after X and Y axis goes to the recorder. This is a block diagram of NMR spectrometer. Then you can talk about if you talk about the NMR spectroscopy, one of the part is very important, nuclear. What is the nuclear? So the word nuclear comes from the ability of the scientist to manipulate the nuclei of the given atom or compound in order to determine its structure. You can see the no applied magnetic field, and when you apply the magnetic field, it will started to from alpha state to beta state. This that will be used in, it is happening in the NMR spectroscopy. Then we can talk about ring current shift NMR spectroscopy. This is very important, especially in NMR spectroscopy for biomolecules. Ring current shift NMR spectroscopy. This is very nice topic. The ring current creates its own magnetic field. Aromatic ring currents are relevant to the NMR spectroscopy as they dramatically influence the chemical shift proton nuclei in aromatic molecules. Ring current shift are a class of conformation dependent shifts observed in proton NMR spectra of proteins and tRNAs. They are naturally probes of structure. The protein ring current shift originate from the aromatic ring of histidine, phenylalanine, tyrosine and tryptophan residues. So this is a ring current shift NMR spectroscopy. So ring current NMR spectroscopy means the own magnetic field created by the aromatic ring current or the relevant to the NMR spectroscopy dramatically influence on the chemical shift, that is like proton nuclear magnetic aromatic molecules. Okay, you can see that for example of protein you have some aromatic amino acids like histidine, phenylalanine, tyrosine and tryptophan. This will use for the ring current shift originate of aromatic rings. You can see here the picture also you can understood here. Then you can see the addition of hemine like cytochrome C, myoglobin and hemoglobin can be also generated ring current shift, which is this case of particularly large. Ring current effect arise from the circulation of delocalized 5 electrons around the aromatic ring. This step of a local magnetic field in exactly the same manner as a current carrying conductors. Okay, you can see here the protons which are less than about 0.7 nanometer from the ring center, more in the case of heme, experience a chemical shift which may be upfield or the downfield depending upon the location of the proton with respect to the plane of ring. So this is the main concept of the ring current shift, and you can see here the above plane of the ring and the ring current flux lines oppose like B0, and thus the shift upfield is shielding. You can see the in the plane of ring and the ring current flux reinforce B0, and the shifts is downfield, that is de-shielding. The flux due to the ring current has two main consequences. First only, the aromatic ring protons of histidine, phenylalanine, tyrosine and tryptophan lines in the plane of the ring and are thus heavily de-shielded. So which leads to the characteristics resonance position in the aromatic region of the spectrum C chemical shift to 6.5 to 8.2 ppm. The secondary proton derived from other residues may be held in approximity to the aromatic ring due to the tertiary structure of protein. Next one, see, this is the applied magnetic field, how that ring current shift will be happen, and you can see that how that ppm levels will be changed. The picture you can easily understand. Then you can see the chemical shift anisotropy, CSA, chemical shift anisotropy NMR spectroscopy. The word anisotropy means the non-uniform. Anisotropy means uniform, isotropic means uniform. So the what is the magnetic anisotropy means the ununiform magnetic field. Ununiform magnetic field, that is called chemical shift anisotropy or magnetic field anisotropy. The chemical shift anisotropy tensor can be described in three principal components. There are three Euler angles which describe the orientation with respect of molecular frame. Whenever you can go three diagonal elements like delta x, y, z, three axis planes are equal to the chemical shift tensor, that is called isotropic. If at least one of these values is different, then the tensor to be set anisotropic. What is here simple? What is isotropic? What is anisotropic? Isotropic means three diagonal elements x, y, z is equal to the chemical shift tensor, that is called isotropic. If at least one value of this axis is different tensor, that is called anisotropic chemical shift. The chemical shift anisotropy means the orientation depends on the chemical shift and arises due to the effect that it is nuclei to charge distribution are rarely spherical in symmetrical molecules. You can see here the picture you can understood here, the shielding of proton in magnetic field B0 is applied on s orbital, induced magnetic movement at the nucleus and induced current. You can see what are the last one, what are the components of NMR spectroscopy, like magnetic and the probe, console and computer. These four are the main component of the NMR spectrometer. Then you can look what are the probe in NMR spectroscopy. The NMR spectroscopy we will see now, two probes are very important. RT probe, simply we will call room temperature probe. The RF coil and other parts are at the room temperature. That is, second one is a cryogenic probe, the sensitive probe and motor probe. The RF coil and other parts of the cryo hold it 15 to 25 K, the reduced thermal noise, and you can see that the probe that is part of the NMR spectrometer system, which is used to transmit the RF signal to the sample and receiver emitted to RF signal from the sample. So probes are two types, RT probe and the cryogenic probe. Next we can see the some of the NMR command list. Some of the NMR command list must be, you have to write in bold words, like commands are the mainly 5 types: loading sample commands, locking, tuning and swimming commands, creating new data commands, and acquisition parameter commands and processing command. You can see that some general NMR commands what the people they will use. Here you can see that to EJ, IJ, ZCP, AI, DF and AA, and you can see the some of the commands also. You can see here EF, EAPK, ABS based locking, ATMA, top spin and RGA, NS, D1, ZG, these things. And really, if you like this video, thanks for watching this video, and especially heartful thanks. If you Thanks for watching. For please like, share and cap.